Hello again. This is the last video for section D.1 and D.2. In this video, we're mainly going to be solving equations. But before we do, we have one more exercise to do from the last video. Exercise 4, and it's a challenge. It's on page 57. I would like you to try it first, see if you can get it, and then we'll go through how to do it. So I'm going to pause. So how did you do it? Well, I'm going to go ahead and do the first method, the simple factoring, because there's a 1 right here. So it's not going to affect our numbers, and we don't have to do the 4-term factoring by grouping method. And this is still the first, this is still the outer plus the inner, and this is the last. And backwards FOIL is what we're going to do. And we're going to realize that p squared times p squared is p to the 4th. And the factors of the last one are not that bad. It's just 2 and 1. That could possibly only be 2 and 1. We just have to figure out the sides. The outer plus the inner. So I'm going to do my backwards rainbow to check out the outer, the inner, and the outer. And I realize if this was a negative, that 1 was a negative, then it would all work. Might check my first again, check my last, and the outer plus the inner. The same with this one. If you notice, this is a 1 right here. So believe it or not, you can do this the same way. But we're going to have a big situation here because we need an r plus 1 and an r plus 1. To make an r plus 1 squared. You can even put those in brackets if you would rather, and then these could stay in parentheses. 36t squared, that looks like a perfect square to me. 6 times 6 is 12, so if you remember, it's that special formula where this is going to be a 6t and a 6t. It's the a plus b squared formula. Let's write that down. So we need this to be b squared, and double that squared is the middle term. And you can see if you check it, so this is the first, and that would be the first. The last is easy to see. That would be the 36x squared. And then this would be the outer plus the inner. If I look at the outer, that is 6t with an r plus 1. And then the inner is the same thing. And that adds up to 12. So if you wanted to write this like I was going to originally write it, that works too. Without the double parentheses. It's really not needed. So that would be the answer, or the above one. So now let's work on solving. There's a couple of ways of solving quadratics, expressions or equations with squares. One way is called extraction of roots sometimes, or the square root property. So over here on the right, I wrote down the rules of the square root property, which by the way is on D2 page 375 in the book. They just don't call it the square root property. Step 1. What you're going to do is isolate the square term. Like this one, a and b is already isolated, but c is not. And then what you're going to do is take the square root of both sides. When you take the square root of both sides, you should add a plus or minus. I'll just write it right there. So let's go ahead and see what I mean by the first one. So what you're going to do, because you have a squared, if you take the square root of both sides, let me do that in a different color. Now if you take the square root of the left, the square root of something squared, x squared, is just x. And on the right side, it's 3. And you can see visually that if I take 3 squared, it's equal to 9. So it does work. And you can see the answer is 3 here. But there is another answer. Notice if I take -3, it also works. So that's why you add a plus or a minus. You could write it like that, or you could write x equals 3. You don't need the or there. So you could write it like this, or you can write it like this. Let's do a check for that negative. So if I take a -3, let's do this in a different color again. So if I take my original equation and plug in a -3 squared, you can see you also get a 9. The square root property doesn't handle that. So that's why we always add a plus or minus to our answer. So part B, same thing. So we start here. Let's choose a different color. Let's take the square root of both sides. The left side is x. The right side is plus or minus 2. And you could just leave the answer like that, or you can write it the other way. It does make sense that the square root of x squared, if you're, let me do that in a different color again. The square root of x squared is x, since, this is just a little note, x times x is x squared. Just like the square root of 9 is 3, since 3 times 3 is 9, or the square root of 4 is 2, because 2 times 2 is 4. So these are just little notes. Okay, so this one's a little bit harder, but you still do the same thing. The one thing you have to do first, we have to talk about, is do step 1 first. We're going to isolate that square term, not the variable. If you could isolate the variable, you would. So what that means is I'm going to add 3 to both sides first. So on the left, let's draw a line here so we can not confuse these. On the left, you have an x minus 1 squared. On the right, we have a 16. Then let's take the square root of both sides in red. The left side is going to now be x minus 1 instead of just x, because x minus 1 times x minus 1 is x minus 1 squared. The right side, you have to add that plus or minus 4. So there actually is one more step with this one. Step 3, which we haven't talked about, is solve. Sometimes they're not solved for x at the end, like on part C. So I'm just going to add 1 to both sides. You can actually add 1 to both sides right now, and it would be 1 plus or minus 4. So you could leave it like that, but better if you realize 1 plus 4 is 5, or 1 minus 4 is -3. So the two answers there are 5 and -3. So that is one way of solving. The other way of solving is by factoring. If you notice in part D and E, you cannot, or let's look at E, you cannot isolate the x squared term because of this x. You cannot add these together. Yes, you could subtract the 6 on the other side, but you could not combine those together and make it a square term. So the square root property fails in this case. So there's another method. Factoring. We're going to solve by factoring. I wrote the directions over here on the right. Step 1, you always need a 0 first. So we're going to write in the form of ax squared plus bx plus c equals 0. So if you don't have a 0 there first, I'll show you an example of that in a minute, then you need to get that first. Step 2, factor. Part D is already even factored for you if you notice there are 2 factors there. So I'm going to start with D, step 3, set each factor equal to 0. So what we're going to do is set each factor equal to 0. The reason you can do that is when you multiply 2 numbers with one of them 0, the whole thing is 0. 0 times anything is 0. So you can see this here. Like this one, if I solve this, I can add 2 to both sides and solve. And this one I could subtract 1 from both sides. These are the answers. Let's do a little check. You can see here if I plug in a 2 into that original, let's just write down the original. This is just a check. Maybe it should be done in a different color. If I plug in a 2 here, I would get 2 minus 2, 2 plus 1. If you notice, what does that equal to? Well, you would get 2 minus 2 is 0 times 3, which is indeed 0. And the same thing with the negative 1. You could put a negative 1 in for both of these. The first one isn't 0. The first one's negative 3. But the second one is 0. It makes the whole thing 0. So you can see that this is the answer. When one of factors is 0, the whole thing is 0. So let's do E right here. Step 1's already done for us. So this one we need to factor first. So I'm going to go ahead and do my factoring. I'm still going to leave my 0. Let me rewrite it. That looks better. So this is the first. So it would be x and x. This is the last. So it could either be 6 and 1 and 2 and 3, but we want it all plus. So that's why I want 2 and 3. And you can see that works because if you look at the outer plus the inner, it does make that 5. And then I'm going to go ahead and solve each one of these, set equal to 0. This one, if I solve this one, I get negative 2. Or if I solve this one, I get negative 3. And that would be the answer. Let's look at one more example. This is an example where it does not have the 0. Notice how the 0 is not here. For D and E, we both had a 0 first. This only works when there's a 0 on the right. By the way, you cannot do extraction of roots. I know that you want to take the square root of both sides here, but the right side has an x in it, number 1, and number 2. How are you going to, when you take the square root of that, how's that going to simplify? You're not going to be able to figure that out. So we're still going to use the factoring method, but we just want to get it in this form first. We want to get a 0 first. So what I'm going to do is I'm going to subtract x from both sides. And then I still need to add 12. I need to get that 0 there. It's not about solving for x anymore. It's about getting that 0 first. Now I have done step 1. I wrote in the form of ax squared plus bx plus c, where the a, b, and c are constants. Now we can go ahead and do it how we did D and E. I'm going to factor it. Again, this is the first, so it's x and x. This is the last. I need 2 factors of 12. There's a 1 there, so 2 factors of 12. That makes 7. That adds to 7. Oh, 4 and 3, isn't it? So it would be a 4 here and a 3. But I do need both of them to be negative because we want it to be a negative 7. Still have that 0. So now we have the 2 answers by set each factor equal to 0. And then we can solve those. So one answer should be 4. The other answer should be 3. So now I would like you to try this. Try exercise 5. To warn you, some of them are going to be using the extraction of roots, where we isolate the x squared when we can, and others are going to be factoring. Pause this, try it, and we'll come back and look at the solutions. Here's all the solutions to exercise 5. Notice how in the first 2 we did extraction of roots or square root property because you can isolate the square term, there's no x. C and D and E and F all need to be done by factoring. C was already factored for you. D, you just took out what's common. E, that's a little tougher to factor. We had to use the factoring by grouping. Be careful with F. F, there's a 20 there, so I actually had to multiply it out, get that 0 there, saw 2 is common. I could divide 2. When you have an extra 2 there, just get rid of it, because I could divide 2 by both sides, and then I can get the answer.